Hello. Now we've touched on one-sided limits before, but we're going to review them here because they're going to be important for the next section. So this is just going to be a quick, short video. And what we want to look at in the first example here are the limits as x approaches 2. So we're going to take the limit as x approaches 2 from the left and as x approaches 2 from the right. So let's begin by looking at how we approach 2 from the left. So we can use this technique of imagining you're walking along the graph, and what height do you expect to be at? What height do you expect to be at when you reach an x value of 2? Well, I think it's plain to see that as you get closer and closer to the red line where x is equal to 2, then the limit of f of x approaching 2, use the little minus sign here to indicate that you're approaching from the left hand side. You would expect to be at a height of 3. That's the height there that you would expect to be at. Okay, so you'd expect to be at a height of 3. Now do the same thing from the other side. Walk back towards the red line along the graph. Okay, so you walk along the graph towards the red line. This time you're coming from the right, so the limit f of x as x approaches 2, and to indicate that you're coming from the right, use a little plus sign up here in the corner. And you can see, I think fairly obviously, that the height you're approaching is this height here, a height of 5. Okay, so as you approach from the left, you're expecting to be at the red line at a height of 3. As you approach from the right, you're expecting to hit the red line at a height of 5. Because the one-sided limits do not agree, don't agree with one another, that means that the limit of f of x as x approaches 2 does not exist. Okay, so this is a case where you have one-sided limits that don't agree, and therefore the limit itself as x approaches 2 does not exist. Just as a side note, you should be able to tell that the actual value of this function when x is 2, the actual value is 3. So f of 2 equals 3. The actual value is given by the solid dot. Okay, so this is stuff that we learned previously. And this hopefully is just a quick refresher for you. There is your solid dot, so that's the value of the function. Okay, so that's the first example, and we'll go ahead now and look at the second example. So if we scroll down here, and this time we're going to look to see what happens to the limit of f of x as x approaches 5. Okay, you can see that this again is another piecewise function. Okay, it looks like an inverted parabola on the left hand side of 5, and on the right hand side of 5 it seems to be a linear function, a straight line. So in any event, it's a piecewise function. So let's take one-sided limits as x approaches 5. So our red line will give us some sort of an anchor. Now, let's imagine we begin on the left-hand side of the red line, and we walk towards it. We walk along the graph towards the red line. So as we do that, we would expect, I think, to hit the red line at a height of 2. Assuming that this, I don't have a scale here, but let's assume that the scale is increasing in steps of 1. So we would say that the limit of f of x in this case as x approaches 5, and we're coming from the left, so the little minus indicates you're coming from the left, we say the height that you would expect to be at is 2. Again, do the same thing, but this time approach the red line from the right hand side, and in this case x approaches 5 from the right hand side. The plus indicates the right hand side. Again, you'd expect to reach the red line at a height of 2. So that's the limit. The limit is the height that you expect to reach. This time the one-sided limits do agree. So we can say in this case the limit of f of x as x approaches 5 is equal to 2. And x approaching 5, we're not differentiating here between left and right hand side. We're saying the overall limit as x approaches 5 is equal to 2. Now this one doesn't have a dot in it at 5, but if a line doesn't have a break like that, if a line doesn't have a break, you don't need a dot to tell what the value of the function is. The value of the function is just part of the line, and in this case f of 5, the actual value of the function, is equal to 2 as well. The line simply, or the graph simply goes through that point and continues through it, so we don't need dots to tell us the value of the line. It's more obvious than that. Okay, so this is a very quick simple couple of examples on one-sided limits, and really there's not a lot to them. You just have to approach from the left, approach from the right. The red line is a handy trick that I find useful, but you don't have to use it. Again, the other thing to note is the way in which it's written, the style in which we indicate we're coming from the left and coming from the right. The little x approaching 5 with the little minus means you're approaching from the left, 5 from the little plus on the 5 means you're approaching from the right. Okay, thank you.